there. Well, next week we're halfway there. Although week 14 it's just if you're doing the final this week, do the final, and there's no late work to make up on, so it's really just final week. So you got 13 weeks. So we're about the halfway point here. You should be about 3 weeks into your final project if that's what you're planning on doing. I've seen some of the papers. People are like what I'm seeing so far. I am a little behind in grading. I didn't realize I'd forgotten to grade week 4, so I'm going to jump into that tonight. Um, got some code I want to go with you guys. Well, with Jujo and whoever else watches later or pops in before the end of the class today. This week was about data conversion and putting data into the database and stuff like that. We're going to have a quick conversation on the constraints of foreign keys and how to mess with those. So I'm going to jump into it now and share my screen. And share it all. All right. All right. So I'm using the Sequila database here. And the first three things we're going to do are just very simple, straightforward, insert, update, and delete. And we're going to kind of talk about those because there's an interesting thing about how this works. I like talking about how things work behind the scenes because it intrigues me. When I started getting into databases, what really intrigued me is how it worked behind the scenes, how the queries were written, how the machine understood it all. And this is all very interesting because we're going to jump into a giant tangent right now. And something I don't normally talk about right now, but we're going to talk about it. So as we talk about inserts, updates, and deletes, inserts, updates, and deletes. Here is our end user. Okay. And this is his laptop. Really crudely drawn laptop. Okay. And a little laptop. There's a laptop. Okay. And then over here, we've got a database. Now, we know that the end user writes to the database. If I'm making changes, inserts, updates, I'm making changes to that database. Here's the problem. If I have this direct connection between my laptop and the database itself, and I'm making, let's say I'm doing 1,000 changes, right? What happens if the power dies while I'm in the middle of my updates? Well, I'll tell you, nothing good. Because what happens is the database has no idea whether it finished or not. So we have what we call a suspect database, a corrupt database, or for the more, the laugh for the 5-year-olds with us, the dirty read database. Okay, it becomes dirty read because it's not good, clean data. So the interesting thing about our database engines is that they are they're not completely self-healing, but they're pretty much self-healing, right? So I've got my database here. It exists on my computer that's in the cloud or wherever it is, right? And so when I actually write to the database, I'm not writing to the database itself. I'm writing to some, I'll put it here in this that I'm writing to something called a transaction log. I'm just going to call it T log. Okay. So this is really, really interesting. I find it very interesting. So when I update data to my database, the database writes it to the transaction log. The transaction log then writes it to the database. And then the database sends the confirmation that it's done to my laptop. Okay. So here's what happened. I'm updating 1,000 rows here, right? In the transaction log, it has created the structure of the tables that I'm updating. And it's updating it all in the transaction log. And as it's updating and it's writing to it, it has a point where it hits its buffer and then it starts writing to the database. So let's just say, for sake of argument, I'm writing 1,000 rows into my database, and the buffer is set. We don't set the buffer; it's whatever it wants to be. And let's just say the buffer is 100. So after 100 rows from the T-log, it starts buffering those out into the database. So 101 comes in here, one goes. Is that making sense? How that buffering works? Okay. So everything, what's it called again? I don't remember what the acronym is, but every log entry in the T-log is done line by line by line by line, right? So row comes in, it's registered here as a line, goes here. And these things get log numbers. That's not what they're called legitimately, but I can't remember the name of it right now. LSNs. They're called LSNs. Okay. Log sequence number. Okay. So let's say the log sequence number in the T-log before I run my query is 15,000. That's where it is right now. Right? When I send my query over, I say, hey, T-log, I got 1,000 rows coming in. So it knows when it's done, it should be 16,000. Right? So it knows this. So it's waiting for the 1,000. So it gets the first 100 and says, okay, start spooling and spooling and spooling in. When this hits 16,000 and then this hits 16,000, it sends everything's good. The database says, hey, I got everything, thanks. It serves the connection, sends over here and says, hey, we're good. We got the 1,000 rows. But here's what happens. So let's say the connection dies at row 1550. 15,500, right? So there's 500 rows that have been written into here, and then the power goes down. The server reboots out of nowhere. When the database comes back up, right? The database says, hey, we were in the middle of something. We were having inputs done. Were they done? We don't know. And the LSN is recorded in the database as well. And the T-log remembers what was supposed to happen. It remembers what that final number was. So the database goes, hey, T-log, we were getting some updates. We're at 15,450. Or we're at 15,500. What am I supposed to have? And the T-log goes, it'll say one of two things. Oh, you're supposed to be at 16,000. I have the missing 500. Here you go. And even though the power went out and the database went down and everything went cattywampus, it completes the transaction and the database is whole. And they're at the correct number. So this is at 16,000. This is at 16,000. It sends the confirmation. We're good, buddy. But here's the cool thing. Let's say the T-log knows they're supposed to be 16,000 when they're done. The database goes, hey, I'm at 15.5. And the T-log goes, I'm only at 15,750. We're not complete. Okay, roll everything back. So it then says, hey, give me those 500 back. We're starting from scratch. We're going to send an error message saying this didn't get complete. So there is a preservation here to make sure that the database doesn't have bad data in it. Because it may have been 1,000 updates, and we don't want half a table updated. So how does this actually work? So I said it pulls the structure down into the T-log, right? So depending on what's happening, it does one of three things. If you're doing insert, it creates a table, and it's called the inserted table. Okay? That inserted table looks like the table that the data is going into the actual database. It doesn't have the name. It's just called inserted. And so the database, the laptop is inserting the data into this inserted table to make sure it'll match what's supposed to go on the real table. So when it errors out, it never hit the database. It's erroring. So if you do something and it errors out, says you can't do this, it's erroring out in the T-log. It never made it to the database. Okay? So inserts go here, and then they get buffered into the database. If I'm deleting, I create something called, well, I don't create it. Create something called the deleted table. So before it's deleted, this table has all the information that this table has in here. It's called deleted, and it deletes from here first to make sure it can happen. And when everything's good here, it deletes it from the database. Okay? When I do an update, it creates both tables because an update both inserts and deletes. It deletes the old value and inserts the new value. Okay? So that's how this whole behind the things, that's how it works. When I insert, an inserted table is created in the T-log. It matches whatever's supposed to, whatever the table is here, and you start writing to here first. And when everything matches, it starts going into here, and then it's done tracking through this buffering process, the T-log to this. Every transaction that happens in the database is recorded in the T-log, except for one, and we're not going to talk about that today. But there's one that's not recorded in the T-log. Remember, whenever we update, insert, or delete from a table, it's not a bulk. It's row by row. So if I'm inserting 10,000 rows into a table, it's inserting those rows one at a time. It's not doing a bulk load. And that's because of foreign key constraints and prime key constraints. It can't do it. It's milliseconds, microseconds to get it in there. But it's still going R bar, row by agonizing row. And that's how it's recorded in the T-log. The T-log's incredibly handy because you can actually read the T-log. And if something went wrong, let's say if someone deleted a line and you didn't know where it was, you can use the T-log to find it. You can also use the T-log to restore your database back to a point in time. But that is way beyond the scope of this class. But that's how all this works. That's how the inserts, updates, that's how it works behind the scenes. Create an insert table, delete a table, exists in the T-log, matches whatever's going on here, writes to here first, buffers into here to make sure that we are safe. We don't get corrupt data. Does that make sense? Right. It's not something we normally talk about. Other teachers don't talk about this. I think it's important. So here's the code we're talking about. I'm inserting data. I'm inserting into the customer table, store ID, store name, last name, email address, address ID, and active. And if I go here to my customers table, I don't have customer ID here. I have everything but. I don't have create date, I don't have last update, and I don't have customer ID. That's because these are all auto-filled columns. This is it's not identity in this. It's auto increment. And these have default settings. So the default date, the create date is today, and the last update date is today. So these are going to timestamp for today by automatic. And then this will be filled out automatically as well. Nothing else is here. So we gotta delineate everything here. So store ID is going to be 1, first name is going to be James, last name is Kirk. There's the email address, address ID 5, and active 1 is active. And when I run this, it goes in there, no problem, works just fine. So what it created an inserted table, put the data into that, then put it into the database and let me know it got done. Circle the light. Update statement, update film. I'm setting title to Wrath of SQL, where title is 42. What's it right now? So select our film. So right now, oh, sorry, the Wrath of SQL. We'll just change that to on. Run that now. Oh, can't. That would be bad. Okay. Set update. You know what? I'm going to show you. So right here, set update film, set title to the Wrath of Khan, where film ID is 42. I run that. It changes 1. 42 is now Wrath of Khan. But I almost did a really bad thing here. I almost ran an update without a filter. So if I ran this on its own, it would change everything in the Wrath of Khan. So here's a thing I should talk about later. I'm talking about. I don't usually talk about this until week 9 or 10, but here we go. Start transaction. This is a very, very powerful thing. And I don't normally talk about it here, but I'm going to. When I run this, it puts everything I do next in a bubble. So let's say I do this. And I have just changed every title to Wrath of Khan. This is a bad thing. But since I put it in the start transaction, I can run this command and it undoes everything. That is the best insurance policy in the world. Start transaction, run your stuff, make sure it's fine. If it's not, roll back. If it is, commit. That's the other command, commit. If you spell it right, it turns blue. Start transaction, run the query. If it runs fine, commit. If it screws up, roll back. And now you know why this happens. Because when I say start transaction, it never leaves the inserted table. It never leaves the T-log. It does not commit to the database. Make sense? Excellent. So here we go. Now I'm going to delete from customer. Delete from customer, where active is 0, which means they're inactive. And the last update was January 1st, 2023. So if I run this, just that query on its own, I want to see how many we're going to delete. So I run this here. I'm going to delete 15 rows. Okay. So I'm going to delete this right now. And I have an error. Cannot delete or update a parent row of foreign key constraint. So because customer foreign keys to payments, and to jump ahead, foreign keys to rental, I cannot delete anything from customer that exists in payment or rental. So if the customer ID exists in payment or rental, I can't do it. On my transaction. Okay. So I try to do this. It errors out of my transaction. So what I'm going to do is I'm going to delete everything from payment that matches, and that deleted 404 rows. I'm going to delete everything from rental that matches, and that's 404 rows. And now when I delete from customer, it goes fine. The reverse is true. I cannot insert anything into a table. I can't insert anything into payment or rental unless it exists in customer. So I cannot put a customer ID in here that doesn't exist here. Okay. Let's say I make a mistake. Start my transaction here. And I do this. Oh, I can't do that. So it won't let me do that because yeah. I just deleted everything from payment by accident. Okay, let me roll it back. Okay, so now and everything's there again. Okay. Okay. So remember I said there's one thing that's not captured in the transaction log? Okay. Let's start my transaction here. Take these guys and bring you down here. Okay. I'm a select star from dogs. 3 rows returned, right? If I do delete from dogs, I'm going to delete everything in there, but rollback will bring it back. There's a command called truncate table. Now, I'm in the middle of a transaction here, right? So I'm going to truncate those table dogs. 0 is affected. Select star from dogs. Ain't nothing there, my friend. I roll back. Select star from dogs. Still ain't nothing there. Truncate essentially flushes the data with no chance of ever bringing it back. It's there in case you need to purge a table very fast of temporary data. But it's something that you never want to use unless you are absolutely sure. And you never, ever use it in a production database because it's very easy to write the wrong name. Not that I've ever done that before, more than once. I was working at a company called Property Insight. I truncated a critical table that brought the business down for like 2 hours until I restored it from backup. I thought I was being smart. I said begin trans in Microsoft SQL Server. It's begin trans. I began the transaction. I'm like, oops, I rolled it back. Mm-mm. Truncate cannot roll back. All right. Any question on inserts, updates, and deletes? A lot of information there. A lot of background about how it works. But yeah. Next part of this week is formatting data. And I've got a couple commands here about how to format data just for fun. There's a lot of commands. If you do a search on how to format data, there's a tons and tons of different commands to do it. So here, first one, I've got upper and I've got length. Upper converts everything in the parentheses to uppercase. Length tells you how many characters are in that string. So if I run this, I get Mary 4, Patricia 8, Linda, blah, blah, blah. Right? Now you may wonder why you do this. So here's a sidebar on this one. Not every character in a database are ones you can see. Spaces, special characters will sometimes get put by mistake in a data, especially if you're bringing it in from a spreadsheet. Sometimes special characters come in, like I don't know if you all know there's a term called carriage returns. Like when you hit enter on your documents, that triggers what's called a carriage return. So it goes next thing, and that's actually a little symbol that's invisible. And if you put that into a database, it comes in and it's there. So if I run this and I see that Mary has 12 length in it, that means there's some hidden stuff in there. So I got to get rid of it. Okay. Here we go in title, rental rate times 2. Just a simple math function. So there's the regular rental rate, and there's the rental rate if I double charge you. Okay. Again, that's just a very simple way to do things. Here, we're going to check a late return. I'm selecting the rental ID, the customer ID, the rental date, the return date, and then I'm adding 3 days as the date that it's due. So date add, I'm adding to the date, rental date, and then interval 3 days. So I'm adding 3 days to it. And I run this select query. That's the date. That's when it was due. I can do 10 days. I can change that to hours, months, years, whatever I want it. But just interval and how much, what the interval I want it to be. So here, this is add to it, and then this is subtract to it. So I'm adding 3 days, and here I'm subtracting 3 days. So that's when I know the date was due, when it was due. Making sense? All right. This is a fun one. Date format. If I just do rental date, and run this, that's what I get. However, if I use this command date format, I'm formatting a rental date, and then I have all these little symbols here. Okay. This is what they mean. Percentage Y, 4-digit year, percentage lowercase y, 2-digit year, percent M, full month name, numeric month, so on and so forth. That's all this does. So here we've got capital W, which is full weekday name. Then we've got name of the month, the full name. Then we've got the day, the full year, the hour, the minute, and the second. So when I run it now, it looks like that. And that's much prettier. Much, much prettier. Last one here, there's a command called cast. What cast does, it turns one data type into another. Now, this doesn't always work. If you're trying to convert a varchar into an int, nothing's going to make that happen unless it's actually a number in there. But if the word Bob is in there and you try to cast it into an int, it's going to fail. But here, rental date is a format called date time. So I've got a data type called date, and I've got a data type called time. So I'm going to cast rental date into date. I'm going to cast it into time, and I'm going to take it out of 24-hour time, put it in 12-hour format. Because when you look at it here, rental date is in military time. So when I run this, I've converted this into these two. And I've separated them. Okay. That is the extent of today's lesson. A lot of information here, and it's just you and me, Joe, so it went pretty quick. But do you have any questions on any of this?
Not right now, no.
Is it you little drinking from the fire hose?
Yeah, that's right. Uh,
So, so yeah, so this week's lesson is all about how to convert data, how to insert, update, and delete, do all that stuff. So you'll get a good feel of it. This stuff may or may not be on there. I don't really. I got to be honest. I'm looking at the quizzes with you guys because my partner, one of the other teachers, rewrote the quizzes where I rewrote writing assignments and all the other stuff. So I'm taking the quizzes with you guys. I haven't taken this week's quiz yet.
Sounds good.
Or the exercises too. So, but yeah. So, and this is stuff that we never taught before. This is all we actually, when we read the class, we looked at what was the lesson that was supposed to be taught, and the exercises never matched it. Now they do. So, mazel tov on that one, right? So yeah, these are some of my favorite things to talk about because next to like how things work behind the scenes, is because we can manipulate this data to make it look however we want it to, and make and give people like the data that they need to see versus the way what they want to see. So,
Yeah.
okay. So if you have no questions, I'm gonna call this a little early tonight. Um, how are you doing your final project?
Um, I mean, I think it's been pretty good progress. I think the schematic looks pretty good for it. It's just what I'm going to use for the input. There's a lot to it. It's going to take a while. That's all.
Well, you can wait, keep on. So a couple of things here. Um,
What time for studying?
and you can absolutely use AI to generate the answer statements. If you tell it, like, show it the table and say, please generate X amount of rows of data for this table, you can do that. And make sure it ties into everything else. So that'll help you build out that fast if you need to insert table. But when you're doing these, I don't know if I told you last time, but after you get the ERD done, you know the data, how the data is going to flow, right? Before you insert the data, write your test cases. Because the way I grade the project is I take your code to create the database and I create the database on my machine. And then I insert the data that you give me to insert. And then I run your queries. And the queries have to return stuff. Right?
Yeah.
So if you make the queries first, you'll know exactly how much data you need to put in your database. You don't need to populate this with like thousands of rows of data. All I need is 2 or 3 rows that come back to show me that the query works right. So once you write the test cases and you say like, okay, I'm gonna write like show me, what books were written by the author Herbert, right? So in your table you've got to have books written by Herbert and an author named Herbert, right? So you just put enough data in there to get those out. But you can absolutely, if you want to just if like if you're doing an author table and you're not sure like what authors to use, you can go into AI and say, here's the schema of my table. Please write me an insert statement adding 15 authors, and it'll generate the query for you. And that's perfectly okay to do.
All right. Yeah, I totally might do that. Yeah.
I mean, the interesting thing about BYUI at the moment is it's really leaning into the responsible usage of AI as opposed to like other places that are either shunning it or teaching it to blackmail you, which was just a really weird article I read.
It's,
They programmed an AI system to understand blackmail, and when they said they were turning it off, the AI tried to blackmail them into leaving it on. So the AI had access to the internet, so I don't know what it would find. So it's just best not to mess with it. But in this case, absolutely lean into it and like use it to help you write. Um, don't you've already made your schema, so don't use it to make the schema, but like absolutely use it to write those insert statements because that'll knock them out really really quick.
yeah.
You can even, I mean, if you're doing the book thing, you can even say like give it like the 3 tables and write insert statements to fill all 3 of them, and it'll write stuff that'll like give you tables, books, and publishers, and give you the cross connection. So but I have no problem. I think it's very responsible and level-headed thinking to use AI to generate the data because that makes it a lot easier for you.
Yeah. Yeah.
All right. Well, sir, thank you for coming by, and we'll talk next week.
Sounds good. All right. Thank you.
Here, bye.